trying to extend the domain yesterday. I just rewritten the steps here, just so that it would be easy for us to do those things. Those steps are actually in this document also that you were following yesterday. This is what we are doing. So cluster creation step by step. These are the SOA cluster related stuff, but before we do those things, we're creating a cluster. Means before we go ahead with specific steps, we have created a domain yesterday on box 1. Then we're trying to extend it to the second box. Then once we extend it to the second box, see this one, these are the steps that we discussed yesterday. Then we will configure the UDDs, we'll configure the coherence, and we'll configure the GOC, all the three. But that will be after the domain is extended to the second box. Then we'll go ahead and configure the OHS part, which will act as a load balancer in the front end. But for now, okay, let me do this thing. The extension part, I'm moving on to the starting. So this is what we are doing at this point. We have I just rewritten these steps just to make it easy. Installing SOA on both the boxes. On box 1 we have installed yesterday and we have created a domain also. Box 2 will be installing today. And then we have created a cluster domain yesterday with all that MDS and other stuff. Then we'll perform this tarring this domain home, transferring and extracting it, the tar onto the box 2, and then we'll be ready to start the source. So at this point we're done with step 2 and partially step 1, means the SOA is installed on box 1 but not on box 2, and that's where we stopped yesterday. So what I'm going to do now is I'll go to the box 2 and then let me put our cluster. Yeah, this is what we are trying to create. This is a setup. Okay, let's go ahead. So let me connect to both the boxes. So this is box 1. Then let's connect to a second box. Oops. Looks like the IP of that box has changed. Just give me a moment, guys. That did not change. It's actually the same IP. Ping 192.168.128.3. Yeah, I'm able to ping that box. This is the second box. Yesterday we stopped at SOA installation. SOA B3. These are our files. Alright. So I'm going to extract these 4 files first things. mkdir, let's say my SOA on chip. -D basically tells where to extract it. If you don't give -D, it will extract in the current directory. Now ideally, instead of installing on both the boxes, it can also be done in a way that you have a common shared file system, and on that file system you install it, and that would be accessible to both the boxes. That also can be done. But the problem with the shared file system is if the file system itself is down, your entire cluster is down.
Anil, a quick question. In that case, like the managed server will be still on the local drive on a different box, right?
No, you are putting everything on the shared this thing, right? So okay. If the shared drive is out, both your managed servers will be out.
So if there is a case where say like on first box there is an admin server and managed server of SOA, and on the second box you have only managed server.
Okay.
Which is like the managed server on the second one is local to that machine.
No, I didn't understand. What's that?
Like if you have 2 boxes.
Okay.
And basically the binaries are installed on a shared drive.
Okay.
But the managed server itself, the log files and like the bin directory, everything on the second node is on the local drive, like it's on the local to the second machine.
But that will still cause problem, because if you don't have the binaries, the core binaries, the WebLogic cannot function.
No, yeah, I understand that, but in terms of like starting it and shutting down.
That part probably it can be done, yes.
Okay. So we have to start up the managed server from local to the second node, or like still from the enterprise manager you can start from the admin server?
Yeah, the managed server, because you are saying it's on a local this thing, it will be started from the local directory.
Local directory, okay.
Yes. I'm transferring other files, the installation script, to the second box, guys. Alright, these 3. So these 3 are for SOA installation. So move my install.sh for our location, sample response file, all these things to my SOA. Let's go to my SOA. This is where everything is. So we have extracted the files. Then this is the script that we're going to execute. This script will require these 2 response files. Now let's look at the script. This is the script. Disk 1 run installer in silent mode. Response file is this thing. we'll be changing the location of this response file. And then inventory location, again we have to change this thing. GRE location, we'll change it to log level finest, force the installation even if the directory already exists. So let me open another session and change these parameters correspond. I'm opening another session to the second box here. Alright, we are again on the second box. Just go to the directory SYP3 mysy. Alright, this is the location and this is the sample response file. Just open the sample response file, make sure everything is good. We won't change too much here, just make sure your skip software updates is true, because we don't want any software updates, and specify download location is false, because we are not updating anything. There won't be anything to download. Then Oracle home is one thing that we should make sure we are giving it properly, and middleware home is wherever we are creating our middleware. So let's first change those two things. This is where we're going to give it. CD Oracle CD middleware. This is going to be our middleware home. So let's give this location in the sample response file. This is going to be our middleware home. Alright, and the Oracle home will be, the directory name will be Oracle underscore SY, but the middleware home will change. So take this off, put it, that's it. So Oracle home will get created. This is where the SUVA is going to be installed after we finish this thing. And this is a WebLogic server, app server type. Everything else will remain same. So your sample response file is ready. This Aura installation location, Aura inst.loc, you don't have to really change anything here. This will be the location where all the installation of Oracle will happen. And this is the group that is installing that Oracle SY. Alright, all these things we have already discussed. Now let's give the location of these two files in our script, which is this one. So this is the location. So I'm going to open this file vi my install.sh. Okay, my sample response file is this thing. This is the location of sample response file. The same way inventory PTR location also the same thing. GRE location, I think we have to change it. Our GRE location is going to be this. This is our GRT location. Everything else is kind of the same. Let's save it, close it. Let's run it. It's reading the response file. See this one, certified version failed. This is basically a Red Hat 6.4 compatible to, we are running on Red Hat 6, let's say. Alright, but Red Hat 6 is actually not certified. The certified one is Red Hat 5. So that's why it's saying basically the OS certification has failed. Now, in spite of failing the OS certification, we can actually move ahead and finish it because Red Hat 6 is definitely, it will have backward compatibility with 5. It's just not certified yet. So let the installation go on. In the meantime, we'll proceed with the next steps. Let's look at the next steps in the domain extension. So this installation is going on. We have already created a cluster on box 1. Now let's go ahead and finish the third step. We'll be tarring the domain home. Let's go to the box 1, which is this. Let's go to the location where we have created the cluster yesterday. Oracle middleware, user projects, domains. This is the one that we have created. Encode B3 cluster. Now we want to take a tar of this one, tar CVF. Let's say we call it encode b3 cluster.tar for this directory. So the tar is done. Move on to the next step. Transfer and extract the tar file in box 2. So let's transfer this tar file. SCP. See, the installation is still going on, but we're proceeding with the remaining steps. SCP this tar file to box 2. So 192.168.128.3, and on that box we'll be transferring it to this location. Alright, so that's transferred. So if you go in here, you will have the tar file. But our domain location, if you observe, what's the location? This is the location. So let's create this location. I'm going to create this location. mkdir-path, the entire path. This will create the entire path. The -p part. Otherwise you have to create one directory, get into that directory, create the next directory, like that. So let's go to the directory. Instead, let's first move our tar file into that directory. Move our tar file into that location where we want to extract it. Then let's go to that location. Extract this tar file, tar xvf, this tar file. Cool. So you have this domain extracted on the second box also. So if you go back to the steps, so transfer, extract the tar file into box 2, that's done. We are just ready with server startup. If the installation is done, I'll go ahead and start the servers. In the meantime, we'll start the first server, the first box. So let's start the database. So this copy is still going on. Installation is still going on at 80% or something. So in the meantime, we can start everything on box 1 also. Okay, the database is up. This is a cluster, this is a bin. We don't have the wrapper script, so let's copy the wrapper scripts from our previous domain. cd to encode SYA. I'm going to copy the wrapper script from our previous domain. Copy this thing, start admin, start server, these two. You can copy all the files at a time. So I'm copying file 1, file 2 to SOA v3 and code v3 cluster bin directory. Set it to bin. This is the admin server. Just make sure everything is good. Domain, home, user, projects, domains. Okay, this will change. Let's give the location. This part will remain same. The same way for SOA server also, let's change it. Shift insert. SOA server, admin server port number is here 7100. Yesterday we have given. Alright, this is the script. Now let's put some boot.properties file, mkdir-p servers. What's the name of the admin server here? Let's get the names of the servers. grep target config.xml. Okay, encode ADM is the name of the admin server. So server 1, so server 2 are those two servers. So let's create mkdir-p servers, encode ADM security, that's one thing. mkdir-p servers, so server 1 security. Create a file and copy that file to both locations. Username equal to encode ADM, password equal to encode ADM 123. Now copy this boot.properties file into both the locations. Alright, so boot.properties is ready. Now let's start the admin server. Start admin. This installation is complete on the second box. We can actually start the server on the second box also. So on box 1, so admin server is coming up. Let's say on box 2 we set up small things like boot.properties and other stuff. In the meantime, Oracle middleware user underscore projects domains and code b3 cluster. Let's create it here also, mkdir -p servers. Here there is only one server, so server 2 security. Right, go to that location and create a boot.properties file. pi boot.properties, username equal to encode ADM, password equal to encode ADM123. Alright, let's create a script also, startup script. Bin pi start sova server 2.sh. This admin is almost ready. Okay, the admin server is running on 7100 port. So let's start the manage server and also copy the script of the manage server. So this is the manage server script I'm going to use on the second box also. But for now, let's start it here. So this will go on. This is the log file. Let it come up. And in here, on the second box, we have pretty much everything. This is server 2. IPF admin will remain same. The log file name we're going to change to server 2. Alright. Cool. So let's start the server on second box also. chmod 755 start server 2 start server 2 tail fnf server underscore server 2.log. Okay, the cluster is coming up, guys. So admin is already up. On box 1, our source server 1 is coming up. On box 2, source server 2 is coming up. We can actually log into the console and see how things are going. There's some error, BAM error, that's fine. This is a BAM error. There's a difference in the times of these two systems. You see these things? This is Jan 30th. This is Jan 29th. Ideally, they all have to be same. If you see here, there's a message. There will be a message related to multicast. We'll see that. Just give me a moment. Just trying to synchronize. Now this synchronization, let's see, it's expected to use a unicast messaging model. It stopped. There's a problem. There's a thread dump here, you see. Coherence error. See the coherence error, what the coherence error says. It appears to have been disconnected from another senior member, which is this. It stopped the cluster service. because we did not configure the coherence set. Okay, anyway, let me log into the console and we do a couple of things and then we restart those servers again. That error should ideally get resolved. The point here is, if you see this error, this guy says there's another server here, which is our second box. Alright, and this is the coherence cluster. Now in the coherence cluster, it's not able to reach the second server, which is this. So that's why it's basically stopping the entire cluster service. This will also pretty much throw the same error. The reason why this is happening is we did not configure a coherence cluster yet. The cluster we are configuring is a managed servers cluster. Coherence also requires another cluster, so we'll be configuring that one. That's a part of our this thing. See this one, configure coherence. So that we'll have to do it. And when we restart, ideally this problem should get resolved. So what I'm going to do is I'll shut down these two servers, only keep the admin server up, and then try to finish the remaining. Let me kill the servers. This is second box. Okay, the same way this is first box. I'm going to kill only the managed server. Just make sure you're killing the correct one. This is server 1. Okay, so I'm going to kill this server 3058. So our admin is still running. This is admin. Alright, now let's log into the console. Seven one zero zero. Code ADM and code ADM 123. Okay. Now let's configure the remaining things. Now if you see here, now this configuration can be done in a couple of ways, guys. So we are trying to configure these three things now. Now we have created a cluster using config.xml, config.sh. We need to create a UDT. We need to configure the coherence cluster. We need to configure GOC. Now all these things can be done either from the console or from the command prompt. Now we'll try to, the easier way is to do it from console. So that's always a recommended way, but it can also be done from command line for those who want to do it on command. So what I'll do is, instead of complicating, I will do it from console. This document already has information about command prompt. So for, let's say, creating a saw UDT thing, this is how you do it. The saw create UDT.python script is already there in that location. We have to execute it for this cluster. Now let's go ahead and do it from console. The same steps I'm doing from console. To do it from console, we need what are called high availability power tools. Now the high availability power tools come along with the installation. We need to enable those power tools in console. So what I'm going to do is I'm going to enable those power tools. So here, this is our console, right? Now if you click on this domain name, here you will see another tab, HA power tools. That tab is not there yet. We will be putting that tab by adding certain jar files to our WebLogic console extensions. So this is what I'm going to do. I will pick up certain jar files The jar files, I'll add it to console extensions of our domain. So let's see where the jar files are. The jar files are in this location. This is middleware home. Under middleware home Oracle Common, you have HA Power Tools. Now, these are the three power tools that will allow you to do everything from console. It's a very nice feature, guys. A lot of people, even when I tried working, we tried to work on command prompt. The command prompt was a little messy, so we switched to console. Console is a lot easier. So I'm going to add these var files to the console extensions. So the console extensions is, let me open another file here, another window. That's correct. They are var files that will give additional tabs in your console. You will understand it. Just give me a moment. So let's go to the location of the domain. So okay, now just to explain it one more time. We are trying to get couple of additional tabs in the console. Now using the tabs are basically additional features. Now the features you will see after you add these var files to the console extension. There is a directory called extensions. Yeah, these are SOA cluster related, that's correct. The SOA cluster related things are these things. So let's go to Oracle middleware, user underscore projects, domains, and code B3 cluster. You see this directory here, console extension. This is inside our domain home. This is our domain home. Inside our domain home there is a console extensions. Means console, by adding certain jar files you can give additional features to console. Now all such jar files, var files, they need to be added here. After you add that var file and you restart the admin server, it will pick up that var file. So what we are doing is, I am adding these power tools, these three var files, to this console extensions directory. This is another and a better way of doing the same thing, SOA clustering. So let's go ahead, copy these files. So I'm copying all the files, three, copy star to the console extension. So in the console extensions file I have all the things, power tools, you have configure GOC, you have create UDD, you have the core file itself you have. So you will be able to do pretty much everything related to clustering from this HA power tools. HA power tools is high availability power tools. It's available under Oracle Common HA power tools directory. This is a nice new feature added in the last releases, because configuring everything from command line is becoming really messy. So cluster configuration, they're trying to make it easy. So what I did was this thing. Look at this one. This is our original console. When I clicked on domain structure, there is no HA power tools here. I am trying to bring a HA power tools tab here. Now to do that, I have copied certain files into console extension directory of our domain home. Once the copy is done, I'm going to restart this server now, admin server, and then we log into the console. There will be an additional tab here. So let me go ahead and start the admin server. Here's a project, domains, and code B3 cluster. Stop WebLogic. Okay, so admin is down. Now let's start the admin again. Okay, let's log into the console again. Okay, click on this domain structure. You see this tab here, HA Power Tools. This is because of that additional var files that we have added. Alright, this is the additional tab. So let's configure everything from here. So the first thing we are configuring is creating a uniform distributed destination. Now let's go back to our steps. These are the steps we are trying to perform. Create UDTs. Now the reason why UDTs are required is currently the server has especially normal queues. Let's go into messaging, go into GMS modules. So here, when we run the UDT thing, this will be deleted and fresh queues will be created, which are uniform distributed destinations. See this one, SOA GMS module, right? Later you will see this being removed and you will see SOA GMS UDT module. I'm going to take a snapshot of this one first, just to give you an idea. Print screen. Okay, remember this is our original thing. Okay, this is the original module that we have. We're going to come back to this screen later. This is, so let's go back and create that UDT thing. Go into HCA Power Tools, lock and edit. This is for SOA, BAM, and a lot of other things you can create UDT. So we are creating for SOA and BAM. Go ahead, give the cluster name. That's our server cluster. Alright, move on. Right, activate the changes. Now when you did this one, you will see the log file being updated. See this one. These are things that were actually done. GMS resource, but it's not really that important. We can actually get into the GMS module again. You see this thing again here? This is changed. Earlier, what was it? Earlier, this was the one. SOA GMS module was the original one. Now it is SOA GMS module UTTS. Alright. So that's what has been changed. So that's your UDD being configured. Now if you go in here, the queues topics are all uniform distributed destinations. Earlier they are simply regular queues and topics. Alright, so that's one thing. Let's go back and see. So the configuration of UDDs is done. Now the next thing is you have to configure coherence and you have to configure GOC. Let's configure coherence. Now as I told you, the coherence is a cluster here. So this one here. Coherence works on a different cluster. This thing. Now coherence is basically for synchronizing the composites and partition information across these infrastructures, SOA infra 1, SOA infra 2. Now the coherence itself is running on a separate what is called multicast address. If you see it in our log file SOA underscore server 1, we have started the server last time, right? So you will see a coherence IP address. You see this one? Coherence cluster address. Now if you see this one, this is actually a multicast IP port, and the recommended one is not multicast. A recommendation that the coherence has to be run on unicast, and that's what we have to configure. So instead of this being used, we have to configure the coherence in unicast. And coherence was another product that was bought from a company called Tangosol. Oracle has bought the coherence product from Tangosol company. So that's why you will still see this parameters Tangosol coherence. Now what we're going to do is we're going to add these additional parameters. These parameters can be added in command line in set domain env, or else we can add these parameters from the console the easier way. So you can go into environment, servers, go to the server, let's say so server 1, look at server start, see this configuration general server start parameters. Now here you're going to pass additional arguments. So the Tangosol coherence are the things we're going to pass under arguments here. Alright, so let's go back now. What the parameters that we're going to pass are these. Setting up coherence for deployment. So you will be passing the extra Java options. The extra Java options you are passing is Tangosol coherence WKA1, well-known address, that's what it is called. What usually happens is in a coherence cluster, cluster works something like this. Okay, let's see, this is a coherence instance. This is a coherence instance. And these coherence is also running on the same JVM, guys. Now these are all coherence instances, let's say. When you have multiple coherence instances, you can have as many number of coherence instances as you want. This is usually called a coherence cluster. Now basically coherence is for high availability, means this will store the Java objects, makes it available to the application. Now out of all these coherent servers, when somebody new comes in, the new member will try to add to one of the well-known addresses. For example, the well-known address concept is pretty simple, guys. Let's say in a classroom that we attend normally in a college, there used to be one guy who coordinates everything. That guy knows about, let's say there are certain function getting organized. One guy is a coordinator. If you want to know certain information, you simply go to that guy and get that information. Now the same way here, when a cluster member joins a cluster, instead of contacting any possible number, there are certain guys who are representatives. Those are called well-known addresses. So let's say WK1, WK2, like that. WK2, well-known address 1, well-known address 2, well-known address 3, well-known address 4, like that. You can have 9 well-known addresses. Means there are 9 guys who are well-known, but that does not mean there can be only 9 members in a cluster. The cluster can be any size, but out of that any size, you got well-known guys 9, 1 to 9. Now when you are defining a Tangosoul cluster, you can define these 9 well-known IPs, well-known port numbers, max. But it's not necessary that you always have to define 9. Max is 9. Minimum you can define 1 or 2. So that's what I'm defining. So these properties will go into what is called extra Java properties here. So if I go in back here, these are the extra Java properties. I'm defining a Tangosoul coherence well-known address 1 is our server 1. Tangosoul coherence well-known address port number is this thing, our server port number. The same way, Tangosoul coherence well-known address 2 is going to be our second box. Alright, and then the port number for that one is going to be again different, like that. Now after you define these two, in each of these servers you need to give a local host, local port. Basically it tells, let's say you have 10 guys. In the coherence I said there are 10 possibilities, 9 possibilities, so we're defining these 9 guys. Alright, let's say these 9 guys are in couple of boxes. Alright, this entire thing is in a cluster. All these circles are in a cluster. Now let's say a new cluster is adding, new server is adding. Now if a new server is adding, it can add to any of the well-known addresses. Let's say there are Waka 1, man, Waka 2, let's say here, there is a Waka 3, let's say here. Now what happens here is, let's say a new server is coming in, this one. Now for the new server to come and join the cluster, it can contact Waka 1, Waka 2 or Waka 3, but when you observe it, Waka 1 and Waka 2 are within the same box. Waka 3 is on a different box. So for this server, which when we are configuring, if I tell that some of these addresses are local it would be easy for this server to contact a local server instead of this newly added or newly coming in member contacting Waka 3. It would be better if this guy knows, okay, these Waka 1 and Waka 2 are local addresses. It would be easy. So along with defining the Waka addresses, these are called Waka addresses, guys. In the normal talking discussion, Waka or WKA, you can call it anything. Waka is a general terminology that used. So what we are telling is, along with defining Waka 1, Waka 2, we are also telling if any of them is actually a local to the one that's incoming. So here also in this case we'll be defining a Tango-Sol coherence Waka 1 port 1, Tango-Sol coherence Waka 2 port 2, and for each of the servers, that box Waka we will define as a local Waka also. So let me just go ahead and define it. You will understand. So I'm taking these Java extra properties. So I'm adding it here. So look and edit. Add the arguments. Now you don't add these things, guys. Don't add this parameter. Make sure it's in a single line. Hyphen D's, these are all. We'll change the port numbers later. Hyphen D, Tango-Sol coherence. Tango-Sol coherence management. Tango-Sol coherence management is all. No, I'm not really sure, Shravan. I'll check it out and let you know. This special parameter that you're asking, Tango-Sol coherence management. I'll check it out. So here, Waka 1 port, Waka 2 port. So hyphen D, the D part is coming here. D. Let's say this is 8100. Tango-Sol coherence Waka 2 is on 3. Waka 2 port is again 8100. Local 1 is 6 for this one. Local port is 8100. We are giving the same unicast addresses, guys. So this will be communicating on the IP ports of the servers itself. So this is the IP port of SOA server 1. This is the IP port of SOA server 2. Those two are the well-known addresses in this cluster. And for the SOA server 1, this is the local host local port. Alright, the same things I'm going to put it into server 2 also, except that I'll change the local host to the second one. So I'm going to save the changes here. One more space missing. Where is it? Ah, here. Okay. Yeah. Anything else, guys? Just check the syntax. This is a really messy syntax. Okay, let's go ahead, copy these things, and I'll save it again, activate the changes. So that's for server 1. The same thing we need to do it for server 2 also. So let me do it for server 2. Server name, server start parameters, lock and edit. This is server 2. So I'm going to change the local host to 3. The rest of things will remain same. WCAS will remain same. Save it. Activate the changes. Alright. So those two are done. Now the third thing, which is GOC configuration, which is here, we will do after we start the server. The server should be running when you're doing the GOC configuration. So we are done with UDD configuration. We are done with Tangosol coherence configuration. I'm going to bring up the two clustered servers. Once they are up, then we'll configure the GOC, then we'll test it. So let me start both the servers. I will restart the admin server also, just in case. Admin is also down. Let's start it again. Once the admin is up, we'll start both the servers. Okay, admin is up. Let's start the servers. Start server 1. DAY12 server1.log. Same way, start the second server also. Start server 2. DAY12 server 2.log. And make sure the Tangosol thing is in that this thing, guys. Sometimes it won't get picked up. It didn't get picked up. You see, the well-known address part is not here. The well-known address is not there. No, they are not same as coherent server creation. Coherent servers are for a different purpose. Here we are simply setting there is a cluster. We are saying the cluster internally has coherence. The coherence should use these parameters when any of the servers are joining the cluster or leaving the cluster. These things did not come, guys. They were not picked up. The startup parameters. You see, I can't see anything at all. The well-known address 1, 2, other stuff. They're basically not being picked up. Here also, in this box also nothing. These are all old parameters. Okay, let's do one thing. I'm going to shut down these two servers and then add the parameters from command prompt. Java options, grab Java. I'm going to kill it. Grab Java. That's so the server on the second box is killed. I'm going to kill the manage server on first box also. This is the manage server, server 1. Kill the server 1 on first box. Now I'll add it in set domain. Take a backup of that one. -bkp. Open that file. Go to the end of the file. You will see Java options. So we're going to add that Java options here. This one. So -d tangosol.coherence.waka1 equal to 192.168.128.6 -d tangosol.coherence.waka1.port. I'm looking at these parameters, guys, in the document. Port, that is 8100. Same way -d tangosol coherence waka2 192.168.128.3 -d tangosol.coherence.waka2.port is 8100 -d, the last parameter, tangosol coherence local. Tangosol coherence local host for this one is 6 192.168.128.6 and the port number. Tangosol coherence local port for this one is 8100. Alright, that's it. I'm going to copy the same things to the second box also. We'll also take a backup of set domain anyway. -bkp. Go to the end of the file. Java options is where I'm adding. Java options is old Java options plus the new ones. Alright. Here change the local host and this is going to be 3 for this box. The rest of the things will remain same. Alright. So save it, close it. Here also save it, close it. Okay. Now restart the admin also one more time, guys. Start the admin server. Now you see this thing, parameters. This is being picked up by the admin also. that's okay. So this one, Tangasol coherence Waka 1, Waka 1 port, Waka 2, Waka 2 port, and local host, local port. Yeah, it doesn't, theoretically it doesn't require, but where you usually, any changes to the configuration, you restart the admin server. Whenever you get a chance to restart the admin, don't hesitate to restart it. It's always a good idea to restart the admin. It doesn't take too much time, admin server restart, so couple of minutes delay will solve a lot of problems. Okay, admin is in running mode. Let's start the source. So this was picked up. Let's start the source server on second box also. This was also picked up. Let's see what happens this time. You see this thing? So cluster server 1 in cluster is being brought up in administration mode due to failed deployments. What has failed? And why is it taking so long? The second one? Let's log into the console also. Server state changed to failed. coherence thing has failed to change. Coherence has bound to 8.1. I think the Waka 1 addresses changed. Let me come back to that one. It says some of the deployments have failed. We want to see what deployments have failed. Okay, they are not regular deployment. It means they are something else. Everything else, these things seem to be correct. These things are normal. Okay. Let's kill it. Okay, this is the change I'm doing, guys. I'm opening the set domain env for the Tango Soul coherence. I'm using not the original port of the server. We're opening a new port. Let's say 2000. There's a port conflict happening, so the server will be listening on 2 ports now. So for Tango Soul coherence, there is one IP port. For a regular SOA cluster communication, there is another port. So that is 8100. This is 8200. So I'm changing the port numbers of Tango Soul coherence. Alright, and starting it again. Ah, you see this one? This is not able to reach the admin server. Admin server could not be reached at this IP port. It will try to come in MSM mode. That will fail again. This is causing some problem. This one. Admin server could not be reached. So let me shut down this server. And box 2 is having problems, guys. It's very likely that there is a firewall. So I'm going to shut down the firewall. Service IP table stop. Okay, that's IP tables is the firewall. So I went into root and I did a shutdown of the firewall. Then I'm going to start the source server again. It still says admin server could not be reached at 7100. Now let's hit this, whether if 7100 is reachable or not. I'm going to use a command ZC nc netcat-z. This is to find out whether a port is listening or not. 128.6, 7100. It's not listening. Admin is not up. Ping 192.168.128.6. Ping is going. 7100 is not listening. That's what this says. So let's check it. Let's first check if the admin is up or not. Admin is not up. How come admin went down? Admin is not up. So let's shut down this server also. Admin is not running, guys. So this we killed. Nothing is running. Bring up the admin. Okay, admin is up. Let's start source server 1 and the source server 2 also. Unable to get file lock. Okay, the server is still running, I think. Kill it. Nothing is running now. Let's start. Okay, this time there is no error. Let's add an admin not reachable. For some reason, the server on the box too is having issues. Speaker, it's slow. Is it because of the resources or there is some other problem? Now this is trying to synchronize. This is stopped at admin mode. We stopped at admin mode. There's some other problem. 8100. That's listening. 8200. Coherence cluster is also on. But the server started in admin mode for whatever reasons. Let's see what the reason is. Okay, this is where we have started the server. I'm coming down in the log file. I'm trying to identify if there are any errors. All out warnings. There is an error here. Oracle BAM. This is the one that caused a failed deployment. And this is the one that has actually caused the problem. I think this is because we have removed that BAM server. We have selected BAM, but we did not keep the server. Failed to initialize the application Oracle BAM due to the error deployment exception. Let's see if there are any other errors. If this is the only error, you know what I'm going to try next? I'm going to create a BAM server from console and target this application to BAM server. That will probably lead to some other applications having issues. But that's probably the first thing we're trying to do. I'm killing the source server 1. The problem is because we selected BAM for deployment, but we did not keep the BAM server. We removed the BAM server. We should not have selected BAM at the installation itself. Okay, let's go ahead to console, refresh this page. I don't understand one thing. If BAM server is not there, the BAM application is expected to be on the BAM server. Why is it failing for the source server? Where is that BAM application? This one, okay. Targets. This is targeted to server cluster. Why Oracle BAM is targeted to SOA cluster. Let me remove the cluster targets. This is ideally supposed to be targeted to the BAM SOA or BAM cluster. Okay. I'm going to start the server again. Okay, admin is in running mode. Let's start the manage SOA. Start SOA 1. Let's see on the first box if you still have the problem. If there is no problem on the first box, then we'll start the second box. Okay, looks like this time we don't have that BAM error. This is an error you will come across, guys. This is okay error. Cannot replicate object that is bound to JND. We are not implementing any B2B related thing, so that's okay. We are in running mode, guys. So the BAM was the error. Excellent. Your cluster is up. Let's see the other server. Let's log into the enterprise manager also in the meantime. Encode ADM 123. This is still coming up. Okay. So server 2 is still down. So you have only one SOA intro so far. Once the second server comes up, we should see a second SOA intro also here. This is almost up, second server. Okay, this is also up. Let's refresh this page. Bingo, you got the second one also. What? This is the second SOA intro. Now let's say if the synchronization of the composites is happening. We still have one more step here. Alright. This is JOC configuration. The JOC is pretty straightforward. You go into the console, go to the HA power tools again. Tangle coherence is a little bit the tricky part. Rest of them can be done easily now. So with the HA power tools, it's relatively easy. Earlier, it used to be through the scripts, which are messy. So go to the HA power tools here. Now you see the second thing here, configure JOC. Click on configure JOC. So let's configure JOC for a cluster. So cluster, it uses a discovery port, another port. So so the manage source server 1, source server 2 will be communicating with another port number. So usually the default port number is this one, 9991 or 9091 something. One of these two ports usually give. Let's say 9991 we give. So both on manage server 1 and manage server 2, see this one. This is how it will be. Manage server 1 discover port, manage server 2 discover port. So this is another port that gets opened. So this is the third port. So SOA server cluster has three ports being used. One is by the SOA servers itself, which have listener as listen port. The other one is coherence. The third one is GOC. Now you configure GOC for the cluster, or you can configure it only for few of the servers. Alright. Then you give the list where we want to configure GOC. 192.168.128.6 and 128.3. They are the two host names where we want to configure that GOC. That's it. That's it. The GOC is for high availability of WSM, Web Service Manager, the security. Let's say these two are your security high availability. You have SOA infrastructure right here. Now the security of one infra is not automatically populated to the other one. That will be done by the Java object cache. Usually the idea is coherence should ideally be able to do the caching, means buffer the security related stuff from here to here, but coherence is not yet able to do that. So they are using a different concept called Java object cache to do the high availability or the buffering or synchronization of the security related services across these two SOA infras. So here, out of these two things, coherence is for composites, GOC is for synchronization of OWSM, means the security. Alright, that's a mandatory thing. It's not an optional one. So once you're given this GOC for a cluster and the details of the cluster, go ahead and configure GOC. There is a disable distribution mode. Don't worry about it. For now, I don't get into it. Distribution mode has certain disadvantages, like the one that we are doing. If there are too many updates, the distributed cache will result in decreased performance. So if your cluster is huge cluster and you have too many updates to your security related objects, you do not want a distributed cache. That's when you disable it. But don't worry about it at this point. For a SOA, we don't want to disable distributed mode. So select it. You're done. Please restart all the affected managed servers. You're going to restart all the managed servers later, but that's your GOC configuration is pretty straightforward. Now what I want to show you is whether the coherence is working or not. So what we'll do is we'll simply deploy one composite to one of the SOA infras that gets automatically reflected to the second one. That's what we're going to do. So let's quickly go ahead and deploy a composite. So SOA infra is for deployments. Deploy. So let's give a location, or let me deploy it from the laptop itself. It's a demo application. On to next. We are, let's say, configuring to default partition. We are deploying to more. To next. Deploy. Now we are deploying it to the cluster actually, but now when you select it, you did SOA infra 1 only. Once it is deployed, it actually gets synchronized across both those instances, means it will go on to SOA server 2 also. See this one, this is SOA server 1, this is SOA server 2. You will see the application being loaded into both. See this one. This is done. Fetch to disk from MDS happened. This is also done. See this one here. Demo application was loaded to SOA server 1 here. The same demo application is loaded into SOA server 2 also without we doing anything. So this synchronization was actually done by your coherence. So when you deploy a composite to one server or one SOA infra, it automatically gets deployed to the other one also. So here if you say, once this is done, we'll see that. Still going on. Okay, this is deployment is done. Now if you see this one, see here, we have deployed to source server 1 here. It is automatically reflected here. The same way if you undeploy from here, let's say right click and undeploy. I right click, undeploy. This is the last version, that's okay, undeploy. It will go from so infra 1 also. The same way if you create an instance on SOA infra 1, you will see the details on SOA infra 2 also. So the coherence basically takes care of synchronizing the information across these two. It basically gets in touch with each of those coherence formed cluster using Tangosol unicast, and it also synchronizes across the MDS. Alright, so see this one. We had deployed from 2, it's also gone from 1. So your coherence is pretty much working. Alright, that's your cluster, guys. The cluster creation is a little bit probably difficult, but the steps are like this. You basically create a cluster, extend it first, then you use HA power tools to create UTTs and JOC, and then you use command line to configure the Tangosol coherence. Alright, any questions in here? We'll stop it here for today. We'll see the OHS configuration in tomorrow's session. Any questions here?
So, Anil, what was the issues initially? It was a port issue.
Initially,
For
our
the
first
coherence?
one was the port issue, second one was a BAM issue. Because when we created a cluster, we asked that to install Oracle BAM, but we removed the BAM server.
Okay.
So the application has nothing to target to. That's why it's failing. So what I did was I removed the targets of the application.
So BAM is a singleton, right?
BAM cluster?
Yeah, like a BAM, like a, yeah, it goes only on a singleton. Like, is it it goes only on one node at a time? Is that true?
No, we can put it
BAM
to your
cannot
BAM
be in a
server.
cluster.
BAM servers
It can be in a cluster?
Yeah, it can be in a cluster. You can have BAM cluster, but the internal components of BAM cannot be clustered. Some of the BAM components like ADC and report server, they cannot be clustered. Part of BAM can be in a cluster.
Okay.
Any other questions, guys?
Anil, suppose if we are deploying any composites from the script, so in that case also you don't need to mention any targets, right?
No, you can deploy it to any server. It'll go to both of them. Both SOA and FRUS get automatically deployed.
Okay.
Even if you are using a hand script, that's pretty much same.
Anil, regarding these adapters like FTP adapter and those things, how they work in the cluster, like a high availability?
Yeah, the DB adapter will have a problem. Like, let's say you have a composite. The composite is using a DB adapter. Now, using the DB adapter, let's say the composite is polling a table. When it polls the table, what happens is this is going to be a slight problem. Like this, let's say you have a table in the database, right, with the rows like this, right. Now, basically, you have two SOA instances, SOA server 1 and SOA server 2. Now, both of them are having a DB adapter, alright. So a DB adapter here, DB adapter here. When you have a composite which is running here and here also, obviously because this is a cluster, it's possible that both these adapters are trying to acquire the same row. That's when there will be a contention. That kind of problem can be solved in two ways. One is either make this DB adapter a singleton service, which means only one of these two is working. That's one way of doing it. The other one is there is something called a distributed polling. Distributed polling, it's called skip lock mechanism. What a skip lock mechanism is, if it is, now when a DB adapter polls a row, it locks it. Now when this guy tries to acquire the same record, ideally, unless the lock is released, this guy cannot move on. Instead, what we say is, if there is a lock, move on. Means skip if it is locked. That's what you'll say. So when these two guys are working, one of them is locking, so this guy will come there, it will simply move to the next one. And this guy comes here, he sees that there is a lock, this guy moves on to the next one. So that way, a distributed polling mechanism can actually take care of multiple DB adapters polling the same table, so that there are no deadlocks. So you have two ways to basically solve the problem. Either define this DB adapter as a singleton service, or implement a distributed polling mechanism with a skip lock mechanism. These are the two ways where the DB adapter thing is implemented. All right.
So do you cover regarding the file adapter and FTP adapter, those things too, configuring or no?
DB adapter, we did it already.
Yeah, no, like the other adapters, like common adapters which we use.
DB adapter, file adapter, we did. That is nothing more that that will be much more specific. The adapter configuration is pretty simple always, You deploy the adapter, you configure a couple of things related to the external software that we are connecting to. The
So
DB
if you have
adapter
to
seems
do,
to be the most commonly used one. So that's why we configured it.
so if you have to do it like we can find the information in the manuals, like it will be there for each and every
Yeah, that's right.
type of
Each adapter will have a manual about how to deploy it, how to configure it. So the deployment part is pretty simple. You go to console, deploy it. The configuration part changes according to what is on the other side. Right side means which software we are, let's say if we are configuring a SAP adapter, the changes will be, the configurations will be a little bit specific to SAP.
Okay.
Uh,
Yeah.
That's easy. That's not that difficult. Configuration of adapters is not that difficult. Okay, any other questions, guys? Otherwise, I'll drop off. I'll see you tomorrow. We'll be covering OHS configuration and integration with this cluster. Okay, guys. Thanks very much. I'm running a little late for the next one. I'll see you tomorrow. Yep. Thank you. Thanks very much. I'll upload this video. You will be able to download in 10-15 minutes.